Hi everyone, I'm Jake. I'm senior software engineer at Jetstack, and I'm one of the cert-manager maintainers. And yeah, we're doing everything completely live, so hopefully there are no issues. Uh, so let's get right into it. I'm going to talk about using cert-manager to enable zero trust identities for intra-pod communication. I thought I'd give a little bit of an introduction to cert-manager first. So sorry if you've heard and used cert-manager every day. So cert-manager is an open source X509 certificate management and automation kind of software for Kubernetes and OpenShift. It's really popular. We've got 8,000 or more GitHub stars, over 300 contributors. We've been in the CNCF sandbox since 2020. We're going for incubation right now. And we support a whole wide range of certificate authorities. So if your company's private PKI is any of the more widely used ones, we probably support it, and we can extend to support any kind of certificate authority. So the kind of core feature of cert-manager is quick and easy certificates, and this is how a lot of people get started. So if you just have a cluster on the internet and you're going into your cluster, exposing your services with ingress, all you need to do is stick an annotation on the ingress. Cert-manager will notice, and it will go off to Let's Encrypt and give you a public trusted cert. It just works, and everyone's happy. But cert-manager is kind of a full cloud-native operator, and it comes with a whole load of CRDs to represent X509 certificates, and all of cert-manager's state is stored in the Kubernetes API in like native objects. So our main custom resource is the certificate, which is this one. It's the kind of human readable and in YAML definition of a certificate, including the duration, the DNS names. A user would normally just create this, and then everything else happens automatically. So if you create a certificate, cert-manager will create a certificate request, and these are picked up by issuers or cluster issuers. An issuer is namespace scoped, a cluster issuer is cluster-wide, and the controller is constantly watching all of these, and if your certificate is going to expire, cert-manager will create another certificate request to renew it. So far, so good. So for the kind of ingress example I showed the YAML for earlier, we automatically, like cert-manager automatically notices that annotation and creates the certificate. And then it just kicks off the flow I just talked about. The resulting certificate ends up in a Kubernetes secret, and you can mount that to the pods in your deployment. If you're doing an Acme challenge, we also show the kind of order and challenge status in CRDs, so you can just kind of see exactly what's going on with normal kube control commands or any kind of observability platform that you have that's already Kubernetes native. This is all pretty great, but we've only just touched on like ingress and web PKA. There's so many more certificates inside a Kubernetes cluster. Like all of the components are talking to each other using mutual TLS, and your apps might want to talk to each other using mutual TLS. And it'd be really nice if we could use cert-manager's kind of certificate renewal machinery to reduce all the pain and overhead of managing some of them. So that's the kind of a whirlwind introduction. Don't worry if you didn't follow it. You can reach out to us afterwards, join us on Slack, and look at our documentation. But now we're into the KubeCrash crash course. We're going to talk about practical use for cert-manager. And I'm going to show you how to use cert-manager to establish like mutual TLS between two pods in a Kubernetes cluster. And you don't need to use a service mesh to do this. You can just use our API machinery. So just a quick warning, there's a bunch of code on the next few slides, but it's very similar to the getting started documentation that we have on our website. So don't worry about scribbling it down or frantically taking notes. So our goal is to have established MTLS between two pods. So firstly, we need a private certificate authority. We can create one just using built-in cert-manager issuers. So we have this concept of the self-signed issuer, which will just create self-signed certificates for anything that you send it. And a root CA is just a self-signed certificate. So we're going to create a certificate. We specify in our YAML that it should be a CA because this is a kind of property of the certificate that browsers or services will check to make sure that a non-CA can't sign a certificate. And we say, so we just say, I want a CA and point it to the self-signed issuer. But if you already have existing PKI, this is where you would just reference your existing issuer like Vault or SmallStep or Google Cloud or AWS, private CA or Venafi. But yeah, we're just going to use the built-in cert-manager one. And once we have that, we'll create a second issuer that says, okay, I've got a self-signed certificate and I now want to issue certs from this. Now I've got our private CA. This is what an example certificate resource looks like. And so I've called it MTLS certificate. I want it to renew 30 minutes before it expires and put it in the secret super secure app TLS and sign it for these names from this issuer. Yeah, so cert-manager will also renew it when it gets to 30 minutes before expiring, but you could also specify duration here. This is just kind of a stripped down example. Because it's ended up in a secret, we can then use it in our pod spec. So this is just a normal pod spec. Hopefully you've seen it before if you use Kubernetes. We're saying we're going to take the secret and we're going to mount it at this location, and then our app can consume the certificates. So our app will be ready to serve TLS. But we actually wanted MTLS, so not just the certificate. So there's a little caveat for this. Back when we created the certificate, we should specify the additional key usages that are required for mutual TLS, which is client auth and server auth. Something to remember about like X509 and TLS in general is that just because I said I want client auth and server auth when I created my certificate request, the certificate authority doesn't have to honor what you asked for. So cert-manager's built-in issuers will honor it, but your internal private PKI, it might have some policies on that don't let you do this. Just our demo will work, but there's always caveats. Cool. So yeah, I've shown you an issuer and certificate resources, and the certificates get saved into secrets. This is kind of a problem in enterprise clients though, because the certificate is a private key and a public counterpart. A lot of places don't really want to store private keys in Kubernetes secrets because the kind of RBAC scoping might mean that someone you didn't want to could read that certificate. This is especially important for mutual TLS because anyone that can read the secret can take our identity, really. What can we do about this? So Kubernetes has something called csivolumes, and they're a way of exposing a custom file system to a pod. So don't worry too much about this diagram. I just took it straight from Kubernetes documentation, so it's super complicated. But basically, every Kubernetes node has a CSI driver registration socket, and you can create a CSI driver, tell Kubernetes, hey, I'm a driver for this kind of volume, and lots of cloud storage providers use CSI. Like it's backs the persistent disks on many cloud providers. But we can use this kind of interface to provide files to a pod without necessarily having to store them in a secret. So we have our own CSI driver, and the cool features of these are the private key never leaves the node and it's never sent over the network. Because of how PKI works, a certificate request, the requester signs the certificate request and the certificate authority signs the certificate. So the private key is never sent over the network, but you can prove that you own the private key just by doing the handshake. So yeah, every replica of the application gets a unique key, and we still get the cert-manager benefits of automatic renewal based on expiry, but then because they're not stored anywhere. When the app is gone, the certificates are destroyed. They can't be stolen just by someone cruising through your cluster looking for secrets. Here's the kind of technical flow of how it works. So when a pod's scheduled to a node, the kubelet notices that we need to publish volume, and that it sends that call to our CSI driver, which generates a private key and certificate request. Cert-manager notices there's a certificate request, it signs it with your issuers, and writes it back to the file system, although it's all in-memory file systems, so it's never written to disk. Yeah, and when the pod's gone, kubelet tells us, oh, that pod's gone, and we can destroy the private key material. Everyone's still with me? So what this looks like in the pod spec is, instead of referencing a secret, we just say, here's our CSI driver, we reference the issuer, and we have the name that we want it to be signed for. So the app doesn't need to change, we just change the kind of volume definition. Cool. So I've showed you a lot of code very quickly and a lot of diagrams very quickly, which that's kind of boring. I don't like looking at code on slides, really. So we're going to do a practical demonstration of what I just covered. And it's all going to be live, so hopefully nothing will break. Pray to the demo gods. So this is what I've kind of made as a model of a normal corporate, like, internal app. You have your users, they will hit some kind of authenticating proxy, which will talk to your identity provider, like Okta or Google Cloud sign-in, GitHub sign-in, Azure sign-in, whatever. Your proxy will check against your identity provider whether you're a person and who you are, and then the authentication proxy will let you into the really secure app. So let's see if everything is running. Great. So I have the components that I just showed you. I've got my super secure company app. Oops. My super secure company app, the kind of authenticating proxy, and my auth providers. And what that looks like. Yeah. Got our corporate co single sign-on. Sign in as user. Granted access, and I get let into our super secure app. So far so good. So without mutual-ls, this is kind of an outdated security model. It's based on the fact that the internal network is trusted. So we do all of our authentication here on the proxy. But what happens if, like, someone got into your network through, like, a leaked VPN or just some malware or anything? The app, the kind of super secure app, is trusting my OAuth proxy cookie to work out who I am. But say I broke into your network, I can just hit the app directly and let's just pretend to be a super admin by sending a forged header. And now the app just thinks I'm an admin because there's no mutual TLS, there's no authentication, and the trusted network model is just broken. Whoops, I didn't mean to do that. Let's add mutual TLS. So I'm going to install cert-manager. I'm going to install our CSI driver, and I'm going to set up mutual TLS using our just an internal CA issuer. Nothing fancy. Hopefully this takes less than 2 minutes to start, because it did in all my practices. Maybe I can do a watch. Yeah, let's see what's going on. and demigods have been unkind to me because of my hotel internet. Well, you know what? I'll just carry on, and if the demo reconciles itself at the end, I'll come back and show you that you can no longer break in once we've added mutual TLS. So I said we can do all this without a service mesh, and normally the answer is why. Why wouldn't we just use a service mesh? Normally the question, sorry. So a few reasons, like cert-manager's CSI driver is very lightweight and just focused on pod identity. We actually integrate with Spiffy. We have a CSI driver that provides Spiffy IDs. So you can actually get a usable identity in your pod by using our CSI driver rather than using a service mesh where your ID is abstracted away from you and the service mesh takes care of everything. Service meshes are also kind of really difficult to configure properly. A lot of companies have tried to use them and ended up hiring consultants to manage it for them. There's lots of things to tune and go wrong. Most service meshes use sidecar proxies. They use so then they kind of force all traffic to go through the sidecar proxy. This adds quite a big memory and latency penalty, which it can add up if you're doing like really high performance. If you're doing really high performance like networking stuff, and multi-cluster is quite hard because you have to configure mesh federation. With cert-manager's CSI driver, you can just drop in your existing issuers and you can do MTLS across the public internet because MTLS is designed for unsecure networks. But I presume I haven't convinced everyone because a lot of people use service meshes, and in fact, most people use service meshes. So we integrate with those too. So yeah, if you're sold on service mesh, I don't need to tell you how good they are as well. But service mesh just takes all of the management of MTLS away from you, even more than cert-manager has. You just write your services, and your developers don't even need to worry about, like, in my demo, you have to actually load the certificates yourself and use them for mutual TLS. So that's kind of developer burden. With service mesh, you don't have to do that. And you can kind of centrally configure policy, which is also a pretty important feature in most enterprises. But cert-manager integrates well with quite a few service meshes. So a shout out Linkerd first, because Eliza, if you stick around for the next talk, Eliza will be teaching you about Linkerd. But cert-manager can provide the trust anchor for Linkerd. So Linkerd manages all the mutual TLS, but you can still issue it with a kind of a subordinate CA from your internal PKI using cert-manager. Istio, so we can replace Citadel, if you like, as the cert provider. We have a project called Istio CSR, which it becomes the registration authority instead of Citadel. But Istio can also just use the built-in Kubernetes certificate resources, which we support also with cert-manager. Open Service Mesh has the best integration, I think, with cert-manager because they directly use our CRDs to create certificate requests, which is pretty nice. But yeah, we integrate well with service meshes if you want to use cert-manager, even when you use your mesh. So yeah, kind of summary, cert-manager, we add rich support for X509 certificates to Kubernetes API, support ingress, CSI drivers, you can use our certificate requests directly. And just if you are using cert-manager, we'd love to know. Come and get involved. Come and contribute. Look at our issues. We're on GitHub, CNCF project. Everything's open source. We're in the cert-manager and cert-manager dev channels on Kubernetes Slack. Let's have one last try at the demo. Cool. So now it looks like everything is running. So yeah. So I was saying that I've broken into your company network and I'm sending fake authentication info to the server. So now I've secured it using cert-manager. We can prove I've done it by doing get pods. So between the proxy and the super secure app is now mutual TLS. And if you remember the slide with the code in, I'm using our CSI driver volume, so we automatically get certificates mounted after my internet sorted itself out. So what that means in the web is I've broken into a network, I'm trying to hit the service directly. Oh, we're now using mutual TLS. So it says you've got to send us an HTTPS request. It's self-signed CA, so Chrome complains, but if we just go through that, saying that we didn't provide a client certificate, it's no longer we're no longer authenticated. But if we just go back to the single sign-on, it's validated me from my cookie before, and we're back into the super secure app just as our regular user. So yeah, very whirlwind introduction to cert-manager, whirlwind introduction to MTLS, and yeah, hopefully that was fun, and yeah, come visit us on Slack, check out our website documentation. Shout out to Jetstack on Twitter, and we're at KubeCon as well, so see what we're up to on our kind of KubeCon landing page. And if you want to try some of our technical examples, got loads of technical examples on our blog. Just yeah, thanks for thanks for listening. I guess is there a tiny bit of time for questions?
Thank you. Oh, and for the audience, hi, I'm Risha. I'm from Buoyant. I did not introduce myself in the previous break, but yeah, so we had a couple questions about Jake's talk, and it seems like the demo gods blessed you eventually, which was great. Very
Yes.
brave to do
Thank
this
you for
demo
doing a demo. Always
on
courageous.
hotel Wi-Fi.
Exactly. Very, very courageous, but very cool. Am I still muted?
No, we can hear you.
Okay, sorry about that. I double muted myself just because, in case. I didn't want to mess anything up. But yes, there's tons of questions, Jake. You're not done yet.
Awesome.
Risha, you want to queue up? And first of all, to the person that asked about these sessions, yes, they are being recorded. I don't know how long it will take to post it, but I assume because we have an amazing team behind the scenes, Dave and Wendy are on it. We kind of introduced Wendy from Lumi. We didn't really introduce Dave yet from Buoyant, but the team who's been working behind the scenes is absolutely amazing. So yes, these are recorded. There will be a recording, but we'll try to get some info for you about how soon they will be posted.
The next question, should the cert-manager pod be running for the whole 3 months to renew the certificate in 3 minutes?
No, so this is the best thing about being a cloud native operator. All of our state is stored in Kubernetes CRDs. So like cert-manager, it should be running all the time, but if for some reason it crashes and you didn't notice, but you did notice just before your certs were going to expire and you restarted cert-manager, it would pick up all of its state from before and notice that, this certificate is expiring in 10 minutes, but that's more than 2/3 of the way through the lifetime. I'll go and renew it now.
And the next question, oh, sorry, go ahead, Lisa.
No, I'm seeing another video question. I'm not sure if it was about the whole program or just about Jake's talk. Jake, do you have a YouTube channel or a place where this content lives? Because I know we will probably post the link from the KubeCrash website for this rebroadcast. A YouTube channel is always a good idea. So probably there will be a KubeCrash YouTube channel, which will have everything. But Jake, do you have a place where your content lives where someone can revisit it?
No, but that's a really good idea. Like we have a cert-manager YouTube channel, but we only post our public meeting recordings there. But maybe we should put demos there. That's a great question.
That's a great idea. Yeah. Okay. All right. Jairam, thank you for that question. Sorry, Richard, what was the next question queued up?
Oh yes, Avinash asks, and I mean you had already covered this in your slides, but if you have anything else you want to say about if there's any advantages to using cert-manager for MTLS over a service mesh.
Yeah, it really depends. Like on one hand, the kind of service mesh developer experience is generally better, but if you want a bit more control and you don't want the latency penalty of a service mesh, you should be just using our certificates directly.
Okay, I think those are all the questions that I see. Did I miss one?
Those are all that I see as well.
Okay, cool.
You can shout out.
Yeah.
You can come to us on Slack if we're available on Slack and Twitter. Just if you think of anything.
Awesome. Yeah, and also just because this is sort of a KubeCon adjacent conference, all of us are sponsors of KubeCon, and we all have our KubeCon Slack channels as well. They start with a 6, and then they usually say -KubeCon, and then whatever the name of the company is. So you don't have to be registered for KubeCon to get on the KubeCon Slack channels. You just have to get on the CNCF Slack channel, and you'll see all the KubeCon sub channels. So that is a great place to find us for the rest of the week. Those of you who are joining in the spirit of the KubeCon as well. We will be here all week for those, and those Slack channels usually stay up for about a week after, if not more. So we can keep answering questions there if you're part of KubeCon. And then we all, of course, have our individual Slack channels, and you can hit us up on our community Slack channels for each of our companies.